Hello, welcome back. This is our second lecture on database normalization. If you haven't watched lecture 1, please check the link in the description box below. In this video, we will discuss second normal form, functional dependency, and how to convert first normal form to second normal form using example. A relation is considered in its second normal form only if it is in first normal form. And every non-key attribute is fully functionally dependent on the primary key, which means second normal form avoids partial dependency on the primary key. As you can see in this flow chart, to convert from first normal form to second normal form, we have to remove or avoid partial dependencies. But what are partial dependencies or functional dependencies? Now it is time to discuss about functional dependencies. In functional dependency, the value of one attribute determines the value of another attribute. We represent functional dependency using an arrow. From our elementary mathematics, we read this as A implies B. But in data management system, we read it as attribute B is functionally dependent on A, which means if two rows have the same value of A, they necessarily have the same value of B. Let us use the table from the first lecture. Even if there are redundant data in this table, but it complies with the first requirements of the second normal form. For the purpose of this discussion, let us consider the attributes of this table. The attributes are order ID, order date, customer ID, customer name, customer address, product ID, product description, product finish, price, and quantity. For the purpose of identification, let us label this one as dependency 1. Here, quantity is dependent on two attributes, order ID and product ID. As we discussed in lecture 1, the only candidate key for this table is the composite key consisting of the order ID and product ID. Because there is only one row in the table for any combination of values for these attributes. Example, the transaction in row 3 and the transaction in row 5 have the same product ID. But to know the exact quantity, we have to check the order ID. Therefore, these two attributes will be used as a primary key. So, the quantity is fully dependent on the primary key order ID and product ID. Let us discuss dependency. Order dates, customer ID, customer name, customer address are dependent on order ID. Which means if two rows have the same order ID, they will have the same order dates, customer ID, customer name, and customer address. Example, order ID in the first row is the same as order ID in the second row. Since the other attributes are functionally dependent on it, their value should be the same. Here, the value order date, customer ID, customer name, and customer address. The same logic applies for order ID 1007. But order date, customer ID, customer name, and customer address do not depend on product ID, which is part of the primary key. We call this partial dependency. Next, let us discuss dependency 3. Product description, product finish, and the price are dependent on product ID. Example, the value of product ID in row 3 and 5 are the same. So, we are expecting product description, product finish, and the price to be the same. As you can see, they are the same. But product description, product finish, and the price do not depend on order ID. Just like dependency 2, we call this partial dependency. Since we identified the partial dependencies, let us see how to avoid them. To avoid them, it is like converting first normal form to second normal form. The first step is create new table for each primary key that is determinant in a partial dependency. So let us create a table with order ID. Then the next step is move the non-key attributes that are dependent on the primary key attribute. So these attributes, the order date, customer ID, customer name, and the customer address are dependent on order ID. So we have to add them to the table. And let us call that table as order table. Apply the same concept for the second one. Let us create a table with product ID considered as primary key and add the other attributes and call this table product table. Finally, we need to create a table for the attributes which do not have partial dependency. In this case, quantity is fully dependent on order ID and product ID. Let us call this table order line, which means we successfully convert the table from first normal form to second normal form. If you have any question, please use the comment section below. In the next lecture, we will discuss about third normal form. Thank you and see you there.